Geometry, Lesson 2.6. We're going to begin with proofs using segments. So here we are. We're now going to take the information we've already learned and we're going to put that information in proofs. There are shortcuts and patterns that will help in completing the proofs, and while there's no set method of proving theorems, the following steps can assist you. Begin by identifying the premise. So this is your given information from the problem. Then drop down and identify the conclusion. This is what you're going to prove. You have to have a goal set for where you want to get to. If you were planning a trip, you would know what your destination was before you began the trip. You would make hotel reservations and flight reservations and rental car reservations and plans for activities that you were going to do. These would all go in a specific order. That's what we're doing with a proof. Make a sketch to ensure you understand the theorem. Always make a sketch. Many times the book will show you a sketch, but if it doesn't, make one yourself. Consider any related definitions, properties, postulates, or theorems. In the beginning, we'll be proving theorems, but once you've proved a theorem, you can now use that theorem to prove another theorem. Work backwards from the conclusion if necessary. For some of us, this works really well, and you can start from the end and work towards the beginning. A two-column proof includes clear statements of the premise, which is the given, and the conclusion. This is what we call our proof. A diagram for the proof and columns for the statements and the supporting reasons. The given and proof statements are more easily identified when the theorem is written as a conditional of the form if P, then Q. An example: if a line and a point not on that line exist, then they are contained in exactly one plane. This section includes formal two-column proofs. Proofs involve new skills that would take time to learn. We'll develop strategies and thinking processes as we go. There is a list of postulates and theorems provided in the back of the student text. Many of our proofs will be using the new information you've just learned along with the previous definitions. It will take time to learn how to do these. Do not get frustrated. Just do the best that you can. I advise that you make a list for your notebook that has your definitions, a list for postulates, a list for theorems. And when you do any of those definitions, postulates, or theorems, make a picture alongside it. So, example 1. Let's prove that a line and a point not on that line are contained in exactly one plane. So here we are, we have a picture, and we have a line and a point not on that line. We're going to name this line, line K, and the point is point P. Given: there exists a line K and a point P not on the line. We will prove that there is exactly one plane Q containing K and P. This is what the completed proof looks like. It's very neat and polished, but when it was originally written, it would have been written and rewritten many times before being accepted as a formal proof. We'll begin with one step at a time. So let's go back. We have our given. There exists a line K and a point P not on the line. Our first statement will be the given. There exists a line K and a point P not on the line. Now let's talk about line K. It says here that line K contains 2 points X and Y. Going back to our original drawing, there were no points on the line, so we're now going to add point X and point Y. Our theorem has actually given us permission to do that. Line K contains 2 points X and Y. How can they do that? By using the expansion postulate. This is a postulate that we learned that says a line contains at least 2 points. That gives us the permission. Let's go to the next step. X, Y, and P are non-collinear. Let's look at the drawing. X, Y, and P are non-collinear. What would that be? That would be a definition. That's the definition of non-collinear points. Non-collinear points are points that do not line up on the same line. So remember, collinear points would all be in a row. Non-collinear points will not be. Next step. Points X, Y, and P determine exactly one plane. 3 non-collinear points lie in exactly one plane. That was the plane postulate. How do I know this? I have a list in front of me with all of my definitions that I've learned. And the last step is now what we were going to prove. So in our original explanation, it said there's exactly one plane Q containing K and P. Line K and P are in plane Q. If 2 points lie in a plane, then the line containing those points lie in the same plane. This is the flat plane postulate. On your drawing, what you could do is go ahead and draw a plane around your line and your points. I'll try to draw a plane. I'm going to do this the cheat way. Plane around my points. And by the way, planes, when you draw them, do not have to be rectangles or any particular shape. They can be quadrilaterals. They're a representation of area with a boundary so that everything lies inside there. So now we have line K with points X, Y, and P in plane Q. There we go. Sorry that took so long. All right. So, we had our given, we had our original statement, we have our conclusion, and that can be actually written in your proof when you write the given in. We know that we've proved using each piece of our drawing with a definition to go to each one. This leads us to our next theorem. Theorem 2.6.1. Segment congruence is an equivalence relation. The proof of one of these properties of congruent segments follows. Example 2. Prove the symmetric property of congruent segments. We are given segment AB is congruent to AC. Let's look at that. So AB is right here. Segment CD is right here. They are congruent. We're going to prove that CD is congruent to AB. Now you may look at this and think, oh, this is obvious. But somewhere along the line, someone had to actually prove that this fact is true. We need to remember that any equivalence relation shows reflexive, symmetric, and transitive properties. We learned this from section 2.5 on page 79. That was one of the properties in the table that was reviewing properties of equality. You should also have the properties written with your definitions, postulates, and theorems. So let's proceed with our proof. In this proof, I've written the given, and I've also written the conclusion. I don't have an answer for it yet, but we can put the given on the first statement, and we can put our first information. Once again, here it was in this slide, given segment AB is congruent to CD. There it is. Next step. Because we know they're congruent, we can now state that they are equal. You will see this time and again in proofs. Sometimes you will have equal first and then congruent, but you will use the same statements, properties, and reasons. So AB is equal to CD. That is the definition of congruent segments. What is that definition? Segments with equal length are congruent. Let's go on to the third step. We can now state, and we're doing this because we want our equations to line up with our final proof. So we're taking our CD and we're switching it to the left part of the equation instead of being in the right part. CD equals AB, and why can we do that? Well, we just learned this. This was the symmetric property of equality. If A equals B, then B equals A. And step 4. Segment CD is congruent to AB because it was equal. Because it was equal, it is congruent. Up here, because it was congruent, it is equal. And we know that when we say this, when we go from congruency to equality or equality congruency, we're doing it because the definition of congruent segments. And yes, you can have more than one incidence of the same reasons in a proof. The previous proof brings up the need to define the difference between congruent segments, which are sets of points, and equal measures, which are numbers. When we write segments that are congruent, we place, if this will let me do this, we place segment notation above them. When we write equal lengths, we do not use the line or the segment notation above it. Also, please understand that if we find when we're talking about congruency and equality, with congruency, we find the union of segments, but we add their measures. So if you're being asked to put two segments together, you will not be using a congruency symbol. You'll be using the addition symbol. Let me say that again. If we're asked to put segments of congruency together, you will use the congruency symbol. You will not use the addition symbol. But if you're asked to put segments of equal lengths together, you'll use the addition symbol and not the congruency symbol. Example 3. This next proof will illustrate the concept of congruent segments and measures of equal numbers. So we're given that segment LM is congruent to PQ. We need to prove that LP is congruent to MQ. Now look at these carefully. This is not the same proof that we just did, because we're actually looking at a longer segment the second time. These are different segments. These are different sets of points. So LM is congruent to PQ. Note that in between LM and PQ is a segment MP. This will be vital to our theorem, our proof. So step 1, we have statements and reasons. From our given, we know that segment LM is congruent to PQ. Statement 2, because these were congruent, we can now state that they are equal. So definition of congruent segments. Step 3, this is a new one. Remember that little piece, MP, that I told you about? We need to bring that in so that we can get to our proof that includes it. And we can state that MP equals MP. That's the reflexive property of equality. We learned about that on page 79. That's where it says A equals A. You can use this in proofs all the time. You'll see AB equals AB, or a segment equals a segment. Sometimes you'll see a triangle equals a triangle. It can be used in many different ways. Step 4. We're now going to prove that we can add the original segment, LM. So we're going to add the original segment, LM, there it is, and we're going to add MP. And now we take our second statement, PQ, and we're also adding that to MP. And we're allowed to do that by using the addition property of equality. That was on page 79, and that says, if A equals B, so this could be A and that could be B. So if A equals B, and let me stop and make this clearer. To make this simpler, I'm going to use our original variables that came with our property and use those for the notation. So I'm naming segment LM A and PQ B. So A is congruent to B, which means that A equals B. MP I'm labeling C, so C equals C. And now we can use our property. If A equals B, A plus C equals B plus C. And that comes straight from page 79. And our next step, we're now going to take and we're going to prove the definition of between. Let's look back at our original drawing. And when we've done definition of between before, we often just did 3 points on the line. This time we actually have 4, but the property still works. So L plus M equals LP. MP plus PQ equals MQ. So L plus MP equals LP. So L, M plus MP equals LP. In our fifth statement, we're going to state the definition of between. Or we're going to use the definition of between to move these segments over, getting ready for our conclusion. Let's go back up to the original drawing, and what it's going to ask us is, it's going to say LM plus MP equals LP. So LM plus MP equals this whole segment LP. Then it states that MP plus PQ equals MQ. So MP plus PQ equals MQ. We can do this using the definition of between. Anytime you're adding segments on a line, you'll be able to use this definition. And our last step, our sixth step here, we're now going to take, and we'll be using these two statements, conclusions I should say, LP and MQ, and we're now going to set them equal to each other. Remember that LM and MP were equal. We're equal to MP and PQ. This is right here, the same two statements. They were equal to something else, but now we can make them equal to each other. So LP equals MQ. We use substitution property. And then on our last step, we get to our conclusion. If they're equal, then they're also congruent. Definition of congruent segments. So that may seem confusing, but if you keep looking back at the examples in your book and in the proofs that we've already done, you will see the patterns and you'll get used to it. I have added a slide, actually 3 or 4 slides for homework hints. And use this when you're doing your homework. Numbers 1 through 8, use the definitions and postulates you've learned to give a reason that would make the statement true. As an example, number 1 in your homework. If A and B are 2 points, then exactly one line contains both A and B. What definition is that? Well, we already used that in one of our proofs. It is the line postulate. Number 9. You've never done problems like this before, so you don't know what to expect. So I thought I would help you with a couple of them. If segment KL is congruent to MN, then what? Well, we've learned this from our proofs. We just did it. Then KL would be equal to MN. Remember, if they're congruent, then they're equal. If they're equal, then they're congruent. So now you know how to do number 10. If NP equals UV, then NP is congruent to UV. And that is because the definition of congruent segments for both of those answers. For number 19 and 20, look back at page 84, example 2, to help you with your answer. For number 21, look at example 3, page 80, to help you with your answer. For numbers 22 through 24, check your word bank and look at previous proofs from lessons 2.5 and 2.6 to see similar patterns. And here is the word bank. For 22, it also says look at example 3 for clues. So each one of these is an answer to one of the lines you need to fill in. They are not on the right side of the proof, so I want you to detect the patterns from looking at previous proofs. And then I actually have the proof for 26, number 26. This is for your homework. You need to make a proof, formal proof in your homework using 4 steps. I've put in a new reason that you hadn't learned yet. We have discussed it before, but it's very similar. The transitive property of equality. That's back on page 89, I believe, of your book. And this gives you all of the statements and all of the reasons. Be sure to contact me if you need any assistance. And good luck on your homework. And we'll be continuing on.